Okay, we're at the sink here again, the Sink Science 9, and we have the Subaru radiator fan motor here, adapted over with a magnetic coupler to the turbine. This is a Subaru fan for a radiator fan. I'm going to take the motor out of that and mount it up to the CD turbine here and see if we can generate power out of this motor. Okay, first thing to do will be to dismantle it from its frame. We won't be needing that, so let me get rid of that. Okay, what I'm left with is this contraption here, which is a motor, and it should act as a generator according to theory. Haven't tried this yet. We'll see how it goes. Okay, I'm going to have to mount that up to a magnetic coupler. A magnetic coupler here, and I don't know if you can see, but I'll bring over the turbine. You can see how it interacts and moves the turbine blades at the same time. Well, we're going to mount that to the little motor here. Okay, we'll just get that screwed on there. And there we go. Okay, something should happen out of this arrangement. Now I have to mount that on top of the CD turbine somehow to keep the magnets separated and make it all work. Well, I've got a piece of 6-inch polycarbonate tubing, about 7 1/4 inches long, that I've cut a slot into here. That'll fit over the nozzle for the CD turbine. Now we have a support base for the generator. Oops, I stepped on the dog. Sorry about that, Cleo. Yeah, go have a drink of water. Okay, anyways. Sorry for that little interruption here. You can see how the magnet hopefully will move with the turbine when the turbine goes around there. Okay, let's take it over to the sink and try a little sink science with it. Really sorry, Cleo. Okay, here we are back at the sink in what has been a very difficult sink science episode here. We've stepped on the dog. We had a hose explode and water all over the place. And we had a leak. No! And several other incidents to make it not work. Okay, set up here. We have a Subaru radiator fan motor that's going to be used as a generator. Our wires come out of the motor and go to the AA Duracell battery that we hope to charge here. It's currently on the voltmeter at 1.23 volts. Okay, here we go. I'm going to turn it on, see what we get to start with here. Okay, I've got the you can see the generator's rotating with the turbine quite well. Hooking it up now. It's gone up to 1.26, 1.27 volts. From our initial, that's about 5/100ths of a volt. What's that? 1/20th of a volt, basically, increase. It's definitely affected the RPMs of the turbine as well. Starting to charge the battery a little bit already. So we have a few hundredths of a volt going in. Okay, that's good. Let's see what our amperage is going to be. Well, it reads about 1/3 of an amp right now. Let's see what happens when I shut off the turbine, whether it goes back to plus. Okay, there we go. Right now there's a draw on the motor from the, a draw on the battery from the motor. The battery's actually trying to turn the motor. And that's 0.8 amps. draw. You can see how it's actually trying to move the motor a little bit. Okay, so when we rev it up, it'll go into the minus, showing that the charge is going in the opposite direction. By, well, we have about a quarter amp right now, 260 milliamps, 0.26 amps, 0.25, so about a quarter of an amp or 250 milliamps charging into the Duracell battery, which over a period of time, quite a bit of time probably, a couple of hours or more, it would charge up the battery to a useful level. At least we're getting something out of it. It's charging from faucet water pressure.